Okay, the next example in this exercise is that if you have a root, z is equal to 2 plus I of this equation here, z squared minus 4z plus 5 equals 0, then show that z bar, or the conjugate, is also a root. Okay, so first thing we're going to say is that first thing we're going to say is that z bar is equal to 2 minus I. So we have to prove that this is a root. Now, what we can do here is use the factor theorem. In other words, if we sub this root into the equation, it should turn out to be true. In other words, it should turn out to be 0. So everywhere we see a z, we're going to put 2 minus I in the equation. So we start out, well, we just write the equation, z squared minus 4z plus 5 equals 0. Now, z, we're putting in 2 minus I, and we've got to square it. Minus 4 times 2 minus I plus 5. Now, we're going to figure out, does that equal to 0? And if it does, then yes, that's a root. Okay, so we square this. The first to be squared is a 4. The second to be squared is I squared is minus 1. Minus twice their product will give you 4I in the middle. Minus 4 times 2 is minus 8. Minus 4 times minus I is a plus 4I plus 5. Now we could figure out, does that equal to 0? These two cancel. And you have 4 and 5 is a 9. Minus 1 and 8 is a 9 equals 0. So we have 0 equals 0. So that implies, yes, 2 minus I is a root. And that's that finished. Okay, so the final example in this exercise is that if you're given z is equal to 1 plus 2i, that it's a root of z cubed minus z squared plus 3z plus 5 equals 0, you have to show z bar is also a root, and then you have to find a third root. Okay, so the procedure is, if we know that 1 plus 2i is a root, then 1 minus 2i should also be a root. So we need to check that in this case, because they've asked us to. So what you do is you sub this expression into this equation. Everywhere you see a z, you're putting 1 minus 2i. So you get z cubed, so it's 1 minus 2i cubed, minus bracketing 1 minus 2i to be squared. Now be careful, the minus applies to everything inside of the brackets. Plus 3 times z is 1 plus 2i plus 5. Now you have to multiply out this expression, which is quite awkward. What I've done is I've multiplied the two brackets first, so 1 times 1 is 1. If I add minus 2i and minus 2i, I get minus 4i. Minus 2i times minus 2i gives you plus 4i squared. And then you're again multiplying all of that first expression by 1 minus 2i. Next, within here, you have minus, and I squared is a minus 1 times 4 is a minus 4, and again you have 1 minus 4i minus 4. Bring that down as before. On to the next. You have 1 times this, 1 times this expression here, minus 2i. Minus 2i times this expression here, minus, and I've got a minus 3 if I go 1 minus 4, that's a minus 3, minus 4i, and then again 5 and 3 is 8 minus 6i. Multiplying by your 1, you simply get 1 minus 4i minus 4, minus 2 times 1 is minus 2i times 1 is minus 2i, minus 2i times minus 4i is plus 8i squared, minus 2i times minus 4 is plus 8i, and then again you're rippling in your minus, so that's become a plus 3, plus 4i, plus 8, minus 6i. Now again, 1 minus 4 is minus 3, minus 4i minus 2i is minus 6i. That's a minus 1 times 8 is minus 8. You have 8 and 4 is 12i, minus 6i is 6i, and then you have an 8 and a 3, that gives you an 11 there. These cancel, minus 6i and plus 6i cancel. You have a minus 11 plus 11 also cancelling, and you end up with 0 equals 0. So you've proved then that 1 minus 2i is indeed a root. Now, to get the third root, what you've got to do is first get the quadratic equation whose roots are 1 plus 2i and 1 minus 2i, and that is done by using the formula z squared minus the sum of the roots plus z plus the product of the roots. And we're going to put, so we're just looking for a quadratic in that equation. Sum of the roots is you add 1 plus 2i and 1 minus 2i. That becomes so it's a minus, so it becomes minus 2z, and then the product of the roots when multiplied together is 1 minus 4i squared, so it's like x squared minus y squared, so 1 squared, 2i minus 2i to be squared is minus 4i squared, and that is a minus 1 times minus 4 is a plus 4 plus 1 is a 5. Now we have the expression, which is the quadratic, which of which 1 plus or minus 2i are the roots. So to find our third root, all we've got to do now is, or rather our third factor, all we've got to do is divide this quadratic that we found into the original cubic, and you end up with z equals 1. Okay, so that is the third factor, and to find the associated root, you just say z plus 1 equals 0, in which case z will be equal to minus 1. So your roots are 1 plus 2i, 1 minus 2i, and then minus 1. Okay, so just if you do in that exercise, if you do questions 1, 3, 5, 7, and 10, that should cover you. Okay, thank you.